Hello and welcome to this video on a bit of ancient and modern history. The ancient Greeks are attributed with many different achievements: philosophy, democracy, literature, plays, geometry, and the list goes on. Among these is the contribution to mathematics. You might be somewhat more familiar with this in the form of trigonometry and Pythagorean formulas. During this same time, the Greeks were aware of something modern, educated, and first-world humans still deny. Earth is a round globe. This occurred because the ancient Greeks had a fascination with the night sky. They had careful records of the location of certain constellations, where they would rise and where they would set. A very simple but effective model of the night, except there was always a slight drift away from where it proposed the constellations should be. This is the theoretical reason why the Antikythera mechanism works, a means to calculate where constellations should rise and when. A sort of analog computer, if you will. This whole situation was a problem, and the fact they created something so advanced to try and solve it proves that. The question would fundamentally be something to the effect of, why would the stars move when they should be fixed in place around the Earth? The reason is simple if seen from a point of hindsight, but not so much from the ground up. If you look at the sky directly above you, it is a narrow field of view. It covers a very specific patch of the sky. If you do this every day for an entire year, there will be movement of the stars as they rise and set each night. Except the stars aren't moving. You are, and so your field of movement is moving. This is why you can plot these events over a year. In fact, the Greeks did it over many years. In doing this, you can get a much larger picture of what the night sky looks like than what you would otherwise have access to on any single given night. What happens is that over a year, the position you look at the sky from on the ground each night will be slightly different and off from the original location. This will vary by up to 15 degrees at the maximum. This is 15 degrees north and 15 degrees south, but not east or west. In ancient terms, modern humans have accurate clocks to compare one local time zone to another. The Greeks didn't have that, but they did have another method that we'll discuss towards the latter part of this video. What we do know so far is that the ancient Greeks knew the constellations changed over time in location, and that this corresponded with a change in latitude. This made clear that there had to be some kind of curvature. To confirm that there was indeed curvature of the Earth, they looked out to what is happening at seas with ships. Ships sailing into view from the horizon would have their masts appear, and then the ship would, gradually working its way down. As they went out to sea, the last thing to disappear would be the sails and then the top of the mast. This was then also true if they looked out from somewhere elevated, think of a hilltop or cliff. Even though they could see further, the same phenomena occurred. This meant that there had to be something continuous with the Earth. With some fairly straightforward math and a bit of application, they could begin to figure out what was happening. The math worked even when you start to apply it to samples taken in other locations on Earth. Something difficult but possible for the ancient Greeks. There were some individuals, primarily philosophers, who travelled widely. If you place a very large pole or pillar on the ground at the equator and wait until midday and measure the shadow, you can clearly see there is no shadow when the sun is directly overhead. Now, if you move the pillar south or north from the equator, you can begin to see a shadow being formed and measure how long the shadow is. This is what happened with one philosopher called Eratosthenes. At the time, they were in Alexandria, part of Egypt, and it was accessible from Greece. They had heard accounts that further down in Syene, closer to the equator but still part of Egypt, there were large pillars that when the sun was directly overhead at midday cast no shadow, whereas in Alexandria they did. Eratosthenes decided to travel to Syene and figure out what was going on for himself. On the way, he had the distance measured, and it came out at approximately 800 kilometers. What he figured out initially was that the difference in angle between Alexandria and Syene was about 7 degrees from having the sun directly overhead. A phenomena that could only be occurring if the two cities were on a curved surface and the sun was shining a light directly towards the Earth. The difference in relative position of the center of the sun from each of these locations, if you were to draw a straight line, is how they could figure out that the Earth indeed had to have some kind of curvature. This further added to the evidence that the sun is in a different position relative to the first measure. When combined with existing knowledge, it clearly indicated the world was round. We had plenty of signs based on the events at the horizon, the shadows being cast by the sun, and other phenomena that had been observed. The question was just how round was the Earth? Knowing this, the ancient Greeks could calculate the circumference of the Earth. They just had to use a little creative geometry. Remembering how we mentioned that the distance between Alexandria and Syene had been measured, approximately 800 kilometers. It was also clear that it was 7 degrees. This was just about all the information that was needed to figure out just how round the Earth was. If you take 7 and put it over 360, it's approximately 50. So 7 degrees over 360 degrees is 50. The distance covered was 800 kilometers. 800 times 50 is 40,000. Using these numbers, they were able to calculate it. And remember, they were using shadows cast and foot measurements. We now have the ability to do, fundamentally, exactly the same thing in your own backyard if you are so inclined to do the calculations. Or, if you are more adventurous, do it over a much larger distance. Using modern technology, powered calculators, and the ability to measure using satellites, NASA has done the same thing. What they've calculated the circumference to be is 40,075 kilometers. The Greeks were off by a mere 75 kilometers, or less than 0.2% difference. 0.2% difference for something that was discovered as little as 2,500 years ago, and prospectively as much as 4,500 years ago. Together, the Greeks not just figured out the Earth was round, but also what the circumference was. This information was freely spread throughout all of Greek society, and by at least 500 BC, it was well-known knowledge within academic circles that the world was a circle, and what that measurement came out at. Despite the way the Greeks could do this with sticks and brain power thousands of years ago, despite teaching this for centuries, if not millennia, a concept developed using basically sticks, brain power, and observational skills. Despite everything else the Greeks developed that we hold on to dearly, some people still will not accept that the world is round. Yet, despite there being far more evidence for the roundness of the Earth than there is for the effectiveness of democracy, some people will still not accept the world is round. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.